Hello, welcome back to the WVU Geography 300 video series for geographical data analysis. We have been looking at sampling, why we do it, how we do it. The choice of how we do it is in large part guided by issues of uncertainty. And we want to make sure we minimize our uncertainty so that our sample is as representative of the population as we can practically accomplish. There are different sources of that uncertainty. I'll go through three here. Actually, four, sorry. One way could be right at the outset, you have a poor design in terms of what type of sampling you pick. Perhaps you pick a systematic sampling, but if you are interested in, as I said in the justification for a spatial cluster sample, if you're interested in what happens at small scales and interactions on the scale of meters, but you do a systematic design that is every 100 meters apart, you're not going to be able to measure, simply by virtue of this design, any interaction smaller than 100 meters. So that is one way, picking the wrong type of sampling to measure what we want to measure. One way that uncertainty and error can come into our data set. The second approach would be, and it's sort of out of the scope of everything else here, I'll put it as poor questions. Or measurements. And this gets a lot to things like survey design, which we're not covering. But even if your sampling is good, if you're asking the wrong thing, to take a simple example, if you're looking at, say, weather measurements, and you, for whatever reason, don't collect the rain, don't collect precipitation, you're obviously missing an important component of the weather. Likewise, if you have, say, a leaky bucket, so to speak, for collecting your rain, a leaky rain gauge, okay, that's going to give an erroneous measurement. In a survey design, and this is an example I've heard of many years ago, where a person was trying to understand people in Africa, farmers in Africa, and their understanding and their adaptation to climate change. But when translating from English into the local language, they mistranslated climate change. So they were asking people about the change in climate or weather from year to year. That is close, but people hearing that question would be thinking, well, yeah, of course I know. Some years we have more rain, some years we have less rain. Sometimes it's a hot year, sometimes it's colder. And relating that to what we think of as climate change didn't happen. It was a poor question design where it ended up not being a valid measurement. It was not measuring what the researcher really wanted and intended for it to measure. We'll call that type of uncertainty of validity, where it just wasn't a valid measurement. The other two types of ways ways that we can have uncertainty come into our sample both relate to the size, but through kind of different approaches. And again, this will sound familiar when we recall those error types. The first being sampling accuracy. Now, all other things equal, a larger sample is going to be more accurate. That's not guaranteed, though, when we think about these two issues. So those are both tied in with sampling accuracy. If I go and I want to understand, say, the sample mean of whatever process, the average number of people who took, average number of farmers who in Africa who adapted to climate change. Well, by that survey I gave before, yes, a larger sample is likely to be in a way more accurate. But because of that invalid question, even then it is not necessarily a truly accurate sample. It will, though, always with a larger sample be more precise. So again, distinguishing between accuracy and precision. With sampling precision, if I am, again, thinking about the percent of farmers who adapt to climate change, if I interview 4 farmers, I probably want more, and that's going to give me a very imprecise measurement. I can only have 5 possible answers. 0%, 25%, 50%, 75%, and 100%. Because I only talked to 4 people. If I talk to 10 people, 10 farmers, now I can have precision to the tens digit. 0%, 10, 20, 30, up through 100%. If I talk to 100 people, now my sample can average, my sample value can be precise up to a single percent, the ones digit. 1%, 0%, 2, 3, 48%, 59%. Those are all possible. If I went to 1,000, with an invalid question, it may not be more accurate than 100 people, but it is going to be more precise because I can have another digit added to my answer. 38.9%. 389 out of 1,000. So as I get a larger sample, I'm guaranteed to have a more precise sample, better sampling precision. And if I have a good sample design, if I have good valid questions, if I don't have a leaky rain gauge, it's also going to be more accurate. But if those other problems creep in, it may not be more accurate, even though it is more precise. So those are 4 ways our sample can have uncertainty. We can have a poor sampling design, poor sample setup. We can be collecting basically the wrong things or the wrong measurements within each of those observations. Those can tie in especially to sampling accuracy alongside the sample size, and the sample size is guaranteed to impact sample precision, where a larger sample will be more precise. So as always, if there are questions, please feel free to ask in either the class Zoom or by email. I will see you at the next video. Have a good one.